We're here for a ROCIS webinar entitled Keep a Lid on It, Best Practices for Reducing Cooking Pollution in Homes. ROCIS stands for Reducing Outdoor Contaminants in Indoor Spaces. It's a Southwest Pennsylvania initiative sponsored by the Heinz Endowments. The presenter today is Tom Phillips. He's a researcher from California. He's retired from the California Air Resources Board, and he knows a lot about kitchen ventilation. So, Tom, you want to tell us how to keep a...
Yeah, just basically keep a lid on it, keep it quiet. That's the bottom line. We first published this guideline in 2017, and we updated it in late 2018 when there was some new data there, and now things are really starting to pick up in this field, as you'll find out later. So we wanted to kind of refresh things and update some of the information, but I did not do a extensive search through the literature and the various building standards proceedings, but I'll give you some links and some flavor to those items. In a quick background, I kind of started in this area in '94 when I wrote the Indoor Air Quality Combustion Guideline for CARB, Air Resources Board, and ended up shipping boxes of it all around the country and doing trainings at various conferences. And then, and that's kind of when I met Linda, probably. And the focus was mainly carbon monoxide, maybe moisture, mold, and other combustion pollutants in general. Then I did a remodel of our house in '92, and I'm real sensitive and have a good sense of smell for odors, and my wife's very noise sensitive, so I put in a low noise range system that I custom designed and had to order a radon mitigation fan from Europe that could run 24/7, and it's still running. My kids learned how to use it. And then I was talking to a neighbor the other day, and because a lot of neighbors asked me how to remodel their kitchen with good ventilation and a good range hood, and so I've been sharing this guideline with them and chatting them up. And the friends said, this young mother, she said, I'm now using my range hood a lot. And the young daughter chimed in and said, yeah, the smoke alarm doesn't go off anymore. Okay, these are the basic topics we'd like to cover today. Some background, and then some low emission cooking practice. There's some kind of new tips there for easy things you can do just to keep the pollution, the source of emissions, lower at the stove level and help make it easier to get into the range hood. Then we'll do a Q&A, and then we'll get into the details of designing, installing, and operating a range hood. And then touch on some of the hot and emerging issues and trends, and wrap it up. And I put together some of the more recent resources that you can look into later, and then we'll have a more extensive Q&A. And here's a nice graphic from Chris Stratton when he was at LBL on kitchen ventilation, and it covers most of the basics. So if you need to show this to somebody that doesn't want to read through the whole guideline, they can look at this. And we'll get into the details later, but you can see where the range hood is covering the burners. It's a quiet range hood. They're using the back burner and so on. And then there's other things to work on in terms of covering the pots and pans using lower temperatures. Induction stoves are the big push now to get electrification in homes and clean cooking. And then there's some other items there we'll discuss. Why do we need ducted ventilation range hoods? Well, because they look cool and you want to be healthy, right? No, we want to definitely remove cooking pollution emissions at the source before the horse gets out of the barn and spreads to the rest of the house, to mix metaphors. Also, I noticed in one apartment, and many actually, where the walls were just coated with bacon grease after less than a year of people in there. So there's a lot of grease type aerosols from cooking, and also semi-volatile compounds, which may be gaseous, but then when they cool off, they settle and deposit on your clothes and surfaces and so on, and create kind of a cleaning problem. And unfortunately, open windows and exhaust fans just don't do the job. They're not as effective as a good range hood system. And you can see here in some LBL modeling of an open floor plan, which is kind of the best case situation, and with high mixing rates. A kitchen exhaust does not get CO levels very low, carbon monoxide levels. They shoot right up when you start cooking for about 30 minutes, and then they slowly decay. And so those concentrations are up over the typical air quality standard levels. Now, the good news is that if you have a good range hood exhaust, you can drop those way down and they never get very elevated. And they're well below most health guidelines. Types of floor plans, they got similar results. Now here's a test home study looking at particles with an electric range, wok stir fry, and a basic kind of contractor special ducted range hood. And they looked at various particle sizes. And down on the bottom, you can see where they started cooking for about 10 minutes, and then they just let things cool down, and they were running the range hood. And you can see that the particle levels initially on the bottom left were very low, below the World Health Organization guideline for PM 2.5 at 24 hours. And they quickly shot up to as high as 300 micrograms per cubic meter for the 2-micron particle size. And then with this setup in a real house with 2 people doing the testing, cooking, that slowly declined. And so an hour later, they were still up around 100 micrograms per cubic meter. So you can see that the particles and other fumes tend to really linger and spread around the house if you don't have good exhaust ventilation. So who needs a ducted range hood? Basically anybody that's cooking. And if you're retrofitting or building a home, it's a good time to replace a really crummy hood or make sure you have one added if you didn't have one. And especially for health sensitive populations such as children and pregnant women and respiratory disease patients. The elderly or older folks, persons sensitive to noise and odors, really can use good exhaust ventilation. And especially if you're doing high emission cooking, such as frying, grilling, roasting, broiling, multiple burners, and so on. And especially if you're in a small home in an airtight home. So we wanted to update the range hood guidance and do these webinars to take advantage of the growing recognition of indoor pollution from cooking and its health impacts. There's also more and more good research coming out on cooking pollution and effective exhaust ventilation from Lawrence Berkeley National Lab and TNO in Netherlands and the UK research groups and so on. And now even, I think, more and more in Asia. Also, originally, there was a new test method developed by LBNL, but it was going to take a while to develop it. So that was one of the main reasons that we wanted to get this guidance out to people, because we had now had good data to show what was effective in removing cooking pollution. Unfortunately, the timeline for implementing that standard keeps getting pushed back, and as we'll talk about a little bit later. The other reason that we want to really increase awareness and get people to reduce indoor pollution from cooking is that there's various other programs where they can take advantage of this and implement this in these guidance, such as healthy home asthma intervention programs, home weatherization programs, which actually do include, I think, range hoods is one of the measures that they will pay for. And then remodeling booms occur periodically, and I think there's another one going on now, especially with low interest rates. And the Home Ventilation Institute, we'll talk about later, but they list performance test results for range hoods and various other appliances. So why is cooking pollution a concern? One of the most common complaints is odors. And if you don't have a sense of smell, I guess it's not a big problem, but a lot of us do. And sometimes I wonder if we could train dogs to be good indoor sensors too, because they have such good sense of smell. Moisture is another major concern, especially if you're doing a lot of cooking or letting something simmer all day, and you can build up a lot of water vapor, which can condense or increase indoor humidity, which then increases the risk of mold, bacteria, and dust mite growth. Here's some fun numbers from emission of moisture from different types of cooking, gas versus electric. And you can see that, say, a dinner for 4 people, you get almost 3 pints from gas and only about a pint from electric. When you add that all up for 3 meals a day, you get about 2 pints a day from electric and 5 pints a day from gas stove. So that's quite a bit of moisture every day building up. Now, if you look at the bottom of the chart, you can see that they compare covered versus uncovered, and you get a slight reduction there if you cover the pan just for 6 minutes of boiling. So if you're boiling for a long time, it could be quite a bit. Why is cooking and pollution a health concern? Well, there's various health impacts that we want to avoid, including respiratory effects in children over the short term. Over the long term, cancer and cardiovascular risks are of concern. And part of the reason is that we spend a lot of time in our house, but also we can be near the cooking emissions in the kitchen or right at the stove. So the dose in the personal exposure area or breathing zone can be very significant. And other reasons to be concerned about cooking are that various monitoring and modeling studies have shown that the indoor pollutant levels from cooking can exceed health guidelines for air pollution. Mainly, I think, particles and NO2, and in a few cases, some of the other pollutants. And gas stoves have a very complex mixture of pollutants, as you can see here, the carbon monoxide, which is one of the original concerns, I think. And then around 2000 and on, people started focusing a lot more and getting good data on particles and the very small ultrafine particles. And then NO2 has become an additional focus in the last few years as we're getting a little better data on that. Electric stoves, just from the cooking itself or on residue on the burners, can produce particles as well as aldehydes, which are irritants and carcinogens, and then moisture. And there's some emerging health risks, which are potent food mutagens, such as the heterocyclic amines, which are very complex compounds formed by kind of the overheating of the compounds in the food. And here's a fun study that CARB funded in a test house in California, again, where they looked at various cooking activities. And you can see that most of these particle sizes were down below 0.3 microns in diameter, which means that they can float around for quite a while and they get into the lung fairly easily. And some of the big peaks, over 400,000, were for oven cleaning and tortilla frying. And then down more moderate levels, around 200,000 down to very low levels for lasagna, were for these other types of activities. We also did some tests, if you're interested, where we had a big Thanksgiving dinner and the technicians ate really well, but it was kind of funny because they were from North Carolina. So they did a kind of like a deep fried turkey, I think. Anyway, I think they did that maybe in the backyard instead of in the kitchen, but anyway. This slide is basically from the same study in the test house in California. We looked at formaldehyde and acetaldehyde and compared gas and electric for broiling fish, and the gas and oven cleaning. And the oven cleaning, both gas and electric were fairly high as far as health risks go, but the electric was lower, as you'd expect, not having combustion products. When we looked at broiling, which are the unlabeled broiling fish, the aldehyde levels were much lower and electric was a little lower than gas. So the blue there's formaldehyde, electric is generally lower. And then in looking at personal exposure to cooking, there was an interesting study in Europe, 5 cities, and they did time activity studies and personal monitoring, PM 2.5, I think it was. And you'll notice that over on the right, eating and cooking were much higher median and extreme levels of particles on the log scale on the left. And you can see that some particular studies, Cassino, Italy, and Guildford, England, were the highest in terms of eating and cooking. And it turned out that when they looked at the diaries, these people spent more time eating and cooking. And also they found that the elderly folks and the women had higher exposures. So human behavior, as usual, trumps everything. Here's just an example of the various potential health effects of NO2 from a recent Rocky Mountain Institute report, just to give an example of some suspected effects of not only cardiovascular, respiratory, but immune systems and possibly cognitive type effects and learning issues. So we're going to talk about best practices and cover these general areas of reducing cooking pollution. And we'll start with the source reduction and then get into airflow requirements, capture efficiency, low noise ratings, duct design, installation, and commissioning, and then good operation maintenance and some caveats and cautions. And then we'll have the wrap up and trend stuff after that. So source control, low emission cooking. Low emission sounds cool and trendy, so everything's low emission and low energy now, right? So based on studies by LBL and various folks, cooking on the back burners works much better. Also covering pots and pans reduces a lot of the moisture and odors and particles that may be thrown out of the pot while you're cooking. A non-stick pan and smaller pan areas in a couple studies seem to help. I'm always leery about recommending Teflon type pans though because of other health issues. So I'm not sure that's where I would go. And then also keeping burners and the pots and pans clean. There's a lot of old studies that show the dirty burners put out a lot more CO, and then you can of course burn the residue to create particles. And so I'm trying to clean the bottom of my pans a lot more now. And then cooking at a lower temperature and using oils that have a higher smoke temperature. That is, they tend not to overheat and start smoking as easily. And those include safflower, soy, and canola oil. And so those basically reduce a lot of particle formation. There's also some interesting studies suggesting that if you add salt or pepper to the oil when you first put it in, it will really knock the particle generation down. There's some hot burners for you. They look pretty clean though. Now, the heterocyclic amines, HCAs, the key there is to reduce that chemical reaction, the Maillard reaction that produces them. So you want to do lower temperatures as low as you can. And then pre-cook the meats in a microwave, and then marination of the meats, maybe only half an hour. That really helps. And of course, avoid charring and burning the food. Fried beef tends to also be very high in these mutagens. And this newer study was kind of fun. They coated the meat with black pepper, and it really reduced these HCAs, but it was not very edible. So they experimented with adding other spices to dilute that flavor, and they found that 2 different types of spices. One was kind of rosemary, and the other one was I don't remember offhand what the herbs were, but anyway, they were high in antioxidants. So that's the title of the article is "Good News for Grilling," which I think is nice to have a little bit of good news these days. This is an older story, but it's still around, I guess. There's probable carcinogen in starchy foods that have been charred or burned. It's acrylamide. It's fairly potent. And so the UK has a campaign to say, go for gold, just don't overdo it, and just get a light color in your toast and your chips. And the EU set some regulations on this for prepared food products, and California has some warning requirements. Another way to reduce emissions from your stove cooking is to go electric and have these small types of cooking devices, such as microwaves. You can cook a lot of foods in them, and it's kind of a sealed device, so you don't produce, I think, nearly as many odors and other problems. But I've been preheating water a lot now when I need a big pot of water. I maybe start the pot, but I also start several cycles of heating in the microwave to shift from gas to more electric for now. And pre-cooking vegetables, I do this when I'm stir frying because it's easier to control the vegetables in the microwave. And I just cover it with a plastic microwave cover and a little bit of water. And while I'm doing all the other stir frying, then I add the veggies in at the end. Induction stoves, yay! These are great for all electric, healthy, low carbon homes. And they come in either a stovetop, or a range model, or the portables, which I think only cost, they're under $200. And you can put the portable right under your range hood, so you've still got good ventilation. And the big advantages here are that they're healthier and safer, and they're cheaper, and they're easy to cook on. And a lot of professional cooks are using them now. They're healthier and safer because they produce less indoor pollution from the burner itself. They produce less heat in the home, which is really important in hot weather and climate change. And they don't produce much GHGs, greenhouse gases, if you're using a clean electricity source. And the burner is cool and safe in terms of fire and burn safety. And they are very cost effective when you factor in how much it would cost to put in a gas line in a new home or a major remodel, and also potential time delays given the way things are going now with construction and the pandemic. But you can save several $1,000s, maybe even I've seen numbers over $10,000. And so that basically pays for not only your induction stove, which does cost a little more than a standard stove, but also for some major upgrades in your whole home performance. And they're easy to cook on because they're faster, easier to control than conventional stoves. They're easy to clean. You do need special pans required, but those are readily available. And some local programs have loaner programs, so you can try them out, or you could borrow one from a friend. And when all else fails, just cook outside. You can get solar cookers online. You can make them yourself. There's even these electric barbecues now. And for special occasions, you can tell your spouse that, hey, honey, let's go eat out tonight.
One question I had, you were showing in that European 5-country study that peak exposures happen during cooking and eating. Do you know, has anyone or any of the research papers quantified how those cooking exposures contribute to your total exposure over the course of a day?
I think there have been some that try to do that kind of apportionment. And in this particular study, I don't know if they did. I haven't looked at a lot of this stuff in a while, but I do remember when you have this kind of time activity data, and if you're with a particle counter, you can get real-time data. And I guess the point is, I have a slide in one of the early ROCIS presentations with black carbon for people commuting to work and then going home and so on. And they show a chart where they show chunks of the day and what the different particle concentrations are and what the main activities are. So there you can see, for example, you might have short periods of commuting with real high concentrations, but when you're at home, you have lower concentrations, but much longer exposure times. So when you add all that up on a time-weighted basis, it's those times at home that tend to dominate the total exposure of black carbon, which tends to be a carcinogen and maybe respiratory problems. So it also depends on whether you're looking at, say, a short-term health effect over an hour or two, where short-term extreme spikes of say, particles can be very important, versus long-term lifetime exposures for carcinogens and genotoxic compounds and so on.
We've seen both in the ROCIS monitoring. We see when we're measuring particles and we have a kitchen spike, an indoor generated spike goes up to 30 or 40,000 counts. Sometimes it's a very short duration because the monitor is close to the stove and it drops down within, say, 15 minutes. Other times you can see the peak that it's created lasts for hours. And it's probably due to both the volume of pollutants created plus the natural air change rate or ventilation rate of the house. So those two extremes would determine, in part, how much exposure you're getting from the cooking. Linda, do you have anything?
There's a question just wanting to clarify the differentiation between kitchen exhaust and range hoods.
Case I think was referring to, say, a exhaust fan in the ceiling or wall where it's not right over the stove and there's no hood. And that you see that in some older homes. And also in building standards and current discussions, they're using a generic term called exhaust systems to lump together downdraft as well as range hood systems. Downdrafts aren't nearly as common. And then microwave oven exhaust systems are called, or OTRs we'll get into. Those are similar to range hoods. So they're all kind of lumped together as kitchen exhaust systems, but there's a lot of different colors and variations in the spectrum. Okay, ABC, that's how easy it can be. You want to, for good hood design, that's step one in best practice for range hood design and installation and so on. First, you want to have a good physical design and layout. You want to make sure that your cooking surface is entirely covered. In fact, some people are pushing the sides out further to extend beyond the cooking surface, especially if they have really big burners, high-powered burners, or they are on an island situation where there's no back wall or a peninsula. And that's the B and C dimension that is on the graph on the right. And then install it about 24 to 32 inches above the stove. You don't want it too high because otherwise the fumes will kind of swirl around and spread and not be captured. And you want to get flush up against the cabinets to avoid bypass around the hood when you have overflow from the hood. And it's even better if you put it in the corner based on some studies in Europe. And keep your oven under the range hood if you can. Separate ovens tend to be not ventilated, but it can still be a major emission problem, but they should be ventilated. Low noise is one of the other key factors in best practices because so many people don't operate their range hood because of the noise problems. You can get the noise rating information for about any model on the Home Ventilating Institute or HVI website. And you want to select a hood with a fairly low noise rating, around 3 sones at 200 cubic feet per minute or CFM. That's less than normal conversation levels at 4 sones. And get the quietest hood you can in general at the airflow rates that you'll need. And some manufacturers will list different zone levels for different CFM levels, so you can try to gauge how well that would meet your needs. But be careful about zone ratings that are not from HVI because they may not be accurate. And then finally, if you're super noise sensitive or you can't find a quiet enough hood, you can do what I did. You can put in a remote fan in the attic or on the roof. And there's even silencers available that are in the ductwork that remove a lot of the noise from the high airflow. Hood design, another factor here is the depth and width of the hood itself to create a buffer volume. And that helps capture and hold a lot of the pollutants until they can be sucked out. And also the open bottom makes a difference. Some hoods have their filters tucked up inside there, but some are flush with the bottom, and those don't appear to be as effective. Flow rate is big. You can see on the left versus the right, the higher flow on the right keeps the plume well contained under the hood. And so we generally recommend a maximum airflow rate of around 200 to 300 CFM, but it does depend on the type of installation in your kitchen, the stove type, and the house tightness. And then you want a fan that has multiple speeds so you can operate it at lower noise levels when you're doing light duty cooking. Capture efficiency is the new game in town. It's great to finally have some metric that actually tells you how well your stove works, because most of them don't work very well, it turns out. And the last I heard is that HVI is hoping to have their test procedures and setup ready to go next year sometime. I'm not sure when, because it keeps getting pushed back. And there's been various issues that I won't get into, but it is based on this ASTM test method that's only uses the front burner, so it's fairly protective or conservative. And we recommend getting a hood with a CE rating of 75 to 80% or more at 200 CFM. When we looked at some of the data from LBL, it looked like there were plenty of stoves, range hoods that could meet that. And we wanted to also push best practice and raise the bar and drive the market as much as we could. Here's an example of the test setup using some CO2 injectors at certain temperatures in the front burners. And then they measure the CO2 up in the hoods. Another thing that can improve capture efficiency are these side shields or buffers, where the volume is increased by extending the lip of the hood down straight or sometimes at an angle. And the good news is that you can really reduce the particle levels substantially and reduce the decay period. And consequently, that by removing the particles faster, you could theoretically run the range hood less often once your cooking stops, that is, and save energy. And this was some modeling done by the Dutch group, TNO, where on the top they looked at different hood configurations, going from no hood to a small hood and over to the top right to a good hood with good coverage. And this is at low flow, but you could basically knock the personal exposure at about half, down to 8 micrograms per cubic meter, which is pretty low for PM 2.5. I think it was 2.5. And then when you go to much higher flows, around 177 CFM, you can get it all the way down to about 1 microgram per cubic meter with a good hood and good ventilation. And so the good news is you can get about a 10-fold reduction if you combine those two strategies. This is just a classic vintage hood from a friend's house in San Rafael, where in the old days they had actually had range hoods and they had side shields. And I just noticed that recently, because the reason I was interested in it is that some old activity survey data that we got in California indicated a lot of people were heating with their stoves, especially gas stoves. And it turned out some of these old stoves and homes, northern, especially the Bay Area, had a built-in space heater over on the left there. But it was ducted to the back wall there in most cases. Over the range, microwaves, OTRs. They do have an exhaust system, but it's not very effective. I don't really recommend them from my experience. They don't cover the burners very well. So if you're doing much active cooking and you're on the front burner, you're kind of out of luck. They don't have much volume, from what I can tell, to help contain some of the plume. And maybe most importantly, they're generally very noisy at the high airflows you need to actually capture and remove the pollutants. I did use one recently that was much quieter at a friend's house, but the house still reeked of bacon all day. My friend likes bacon, so. Now, installation. This is where the human factor comes in. On the top right, you see roofing debris found in range hood ductwork in an LBL study, and nails and shingles, and oftentimes you find dead animals too, I guess. So you definitely want to clean out your old ductwork or replace it as needed when you're installing a system. You want to have good duct layout. Use mastic to seal everything. Avoid bends. Have smooth ductwork, not the rippled kind. And double check the duct layout so it's not crushed between framing in your attic. And low resistance sealed ducting, we covered that. Avoid cross-contamination of the air intakes. Make sure your exhaust, where it comes out of the wall or roof, is not near an air intake for some other device. I've run across that in some Airbnb homes where I started smelling oil fumes, and it turned out when I turned on the kitchen exhaust, and it turned out the intake was right near the exhaust for the little oil burner in Ireland. Finally, take a road test, inspect and test everything, the whole system, and make sure that it actually pushes air out the exhaust and it's not too noisy and you're not getting any major leaks. Best practices in operation. This is where the human factor comes in again. These are some fairly easy things to do. Just mark them on your calendar or practice mindfulness, I guess. You want to start your fan before turning on the burner, then operate it at the highest fan speed, at the highest tolerable noise level you can handle. Then, and this is the tricky part, I think, especially my wife, because she doesn't like the noise, I guess, is leave the fan on for at least 10 to 20 minutes. Sometimes I go longer because I can still smell things from hot pans under the stove. But generally, at least do it until the cooking surfaces and pans have cooled, or until you don't notice any smoke or odors. Unfortunately, your sense of smell tends to adapt, so you may not notice it unless you go outside and come back in. Also, clean the grease filters at least quarterly. They just pop out and you can throw them in the dishwasher, or if you don't have that, there's a sink procedure I found and provide the link there where they soak it with a cleaning solution and just brush it. And then oven cleaning cycles, run those periodically, but be very careful because you saw earlier how high the particle and other pollutant levels can get. You want to close up the kitchen to keep it from spreading to the rest of the house, the fumes that is. Then start the cycle and run your hood at maximum speed, but also make sure you get everybody out of the house and your pets, and then clean the grease filters afterwards just in case they've captured a lot of crud. And there's some caveats and cautions. Want to avoid unintended consequences, of course. And one of the issues with exhaust ventilation, shown here, the F on the right is the exhaust fan, that you can depressurize a building and it can suck the fumes down through a fireplace or from a naturally vented combustion appliance. And so you will definitely want to avoid high flow hoods that have 400 CFM or more, because those can depressurize a house and backdraft these other combustion appliances. And it can suck air from your basement where you may have God knows what in there that you don't want to be pulling into the house. And so to avoid backdrafting with these high flow hoods, you want a mechanical makeup air system, not a passive one. You need one with a motor that's interlocked with the hood, and you want to filter and temper the air so it's not too cold and drafty. And then finally, measure the depressurization and airflow with an exhaust fan on to make sure that it's really doing its job and not causing too much depressurization. And another step in this process, especially if you have a tight house, is to measure the tightness of that house. And then there's calculations you can do to see whether you exceed some depressurization limits, because some states and some programs have those, especially if you're in a retrofit, I guess, with the combustion appliances. And then you can calculate the maximum amount of airflow that your range hood should have to avoid too much depressurization. And this is just an example of the chart. I don't think I'll get into it in detail, except to show that, say, with the green line there, if number 2, if you're shooting for a minus 10 Pascal level, which is more than it takes to backdraft a gas fire or oil appliance or a fireplace, if you go to a super tight house down way on the left off the scale, you're talking about maybe only 100 or 200 CFM is all it takes to backdraft that house. So then you definitely want to make sure you have makeup air. And there's just the very tight house, which is a leakage value of maybe 1,000 to 1,500, but some homes are getting much lower now. Okay, what about recirculating or ductless hoods? Well, we don't recommend those for various reasons. I think it's fairly obvious, but some people think they're great, or they don't look at the data, I guess. But the main reasons are that they really are not effective for removing cooking pollution. They don't remove moisture. They may have various filters and devices to capture some of the pollutants, but they tend to load up and not be very adequate. And then there's pretty good data to show that the gas filter effectiveness declines quickly. So for NO2 and aldehydes and the other gases and irritants, oftentimes they're not that great. And then the final nail in the coffin, I guess, is that they're expensive to replace those filters, and occupants do not replace the filters just very routinely. In fact, I think you can assume in most residential situations that there's be minimal maintenance. I mean, people find central air filters that have been in there for decades. So you cannot assume that people are going to maintain these kind of systems. And so pet names for recirculating hoods. This is just kind of a fun reminder of things that various people have suggested. A recirculating toilet, stuff that just goes round and round and never leaves. Forehead greasers from Brett Singer at LVL. And from Lloyd Alter, the most screwed up, badly designed, inappropriately used appliance in your own home. And about 8 or 10 years ago, I labeled them, having not seen these others, I guess. I added them to my list of stupid human tricks for myths and conspiracies on IAQ and so on. And so it's definitely kind of a crazy concept to think that something that's just spitting fumes back into your face is going to do much good. So what are the hot issues these days? Well, all the stars have aligned, at least in many parts of the world, I guess, including California, to focus on cooking appliances. And this is largely because of building decarbonization efforts to get gas appliances and out of homes and electrify them so they can run on clean, low carbon energy. So there is some legislation a few years ago, AB 3232, California, to require the Energy Commission to assess a 40% reduction in carbon by 2030. And on the right, you can see that buildings make up about a quarter of the carbon emissions or greenhouse gas emissions in California. So which is, a substantial chunk, and it's kind of been the last in line after these other sectors. They're finally getting to it. And this report is supposed to also focus on indoor and outdoor air quality, which is great, health and low-income groups and disadvantaged communities. So the draft is supposed to come out this month to address impacts, barriers, and pathways. So we'll see what happens. But some very ambitious goals for California and a lot of other places to get the carbon emissions way down very rapidly, as you can see on the bottom right, by 2040 and earlier if possible. Another part of the climate action in California is the statewide goal by executive order to reach zero carbon by 2045. And over the last few years, over 40 local ordinances have adopted gas bans or gone all electric for new construction and major remodels. And there's also been there still are utility rebates for electric heat pumps for heating, cooling, and water heating, which are some of the major energy hogs in buildings and in commercial and residential sector. And I think kind of as the Energy Commission, which I'll get to in a minute, California Energy Commission was starting to address kitchen appliances or stoves, gas stoves. The Air Resources Board had an informational hearing, which drew an awful lot of public comment and attention. And the information was just on general, indoor quality activities at the Air Resources Board where I used to work, and raised some of these issues about gas stoves and electrification. And the board came out and said, well, it's time for us to actually support building electrification. And even though it had been kind of the climate action plan, it was not really on the agenda until recently. Then they also came up with a great statement to say they're going to support state and local agencies and stronger kitchen ventilation standards and ventilation IAQ interventions, and then engage the community in indoor quality and exposure assessment research. So the California Building Energy Standards and Design Standards that are being updated, the triennial review is ongoing now at the pre-rulemaking stage. And they're considering proposals for new kitchen ventilation requirements. They already had some for noise and airflow rates, but the big new add is the capture efficiency metric, and that's going to be one of the options to comply with the standards. And those go into effect in 2022, I believe. So early next year, the draft standards should come out for public comment. So definitely stay tuned to that and get your 2 cents in. There's also some heat recovery ventilation requirements in there, which will generally improve energy efficient ventilation. I think it's mainly for multifamily homes. And somewhat related to the gas stove issues, they're adding a carbon-based cost metric. They already have a time of use or time-dependent value cost metric, which factors in peak energy pricing, peak demand pricing. But the carbon-based metric will tie it more directly as well to the emissions from that peak generation source or whatever power source you're using for the grid. And there's been extensive public comment on these issues. And so basically stay tuned. It's going to get interesting. Now there's some other building standards, the Cal Green standards, which include a lot of other things besides energy. And there's I think 2 tiers of difficulty and intervention or effectiveness or whatever. And so there's mandatory and then voluntary standards, and cities can adopt all or part of these as there for their local ordinances. They can go above and beyond the state standards. And that update is starting probably this month, so stay tuned to that as well. Now, here's some kind of miscellaneous emerging, or I'd say simmering issues. And I'm listed them here, but I'm only going to touch on the ones in red, I guess. In very tight homes and passive houses, there's, I think, debate and confusion about whether a heat recovery ventilator with boost is enough versus do you really need a range hood and exhaust ventilation, which may defeat some of the air sealing objectives. And then at the bottom, air cleaners and filters in the kitchen exhaust or recirculating system are being produced mostly, I think, in European manufacturers' lines that can be a concern in terms of toxic compounds. So when you actually look at the data for heat recovery ventilators in this Colorado passive house study, Shelley Miller and her group looked at several homes, and you can see that when you compared the standard versus the boost is in light blue, you got a little bump in the reduction of PM 2.5, but not much. And then if you looked at a direct exhausting hood, you got much lower levels in general, and then the boost levels dropped down some, I guess. But the point is that you could get an 85% reduction in the peak PM levels by using a range hood as opposed to using a HRV. And if you used a low flow on the exhaust hood, you got a very slow decay rate as opposed to a high flow. For the new air cleaner technologies and filter technologies, this is one of those stupid human trick type things where it's basically generating ozone and maybe other things there from this plasma generator that's in the exhaust ductwork, and it's just pumping it back into the house. It's called a plasma filter. Whenever you see something cool and sexy like plasma or oxygenated or Mountaineer or something, your red flag should go up because it's probably producing ozone and maybe even NO2. And this Dutch study from TNO folks, they found very high levels of ozone and NO2 from some of these models. Another kind of probably stupid human trick is the ceramic filters in circulating units. There's this downdraft, real cool model from Italy, and you can pull out the ceramic filters in the back there. They look like blocks. And they market this to say, oh, you don't have to buy new filters. You can just stick it in your oven and crank it up. Well, that's probably a very toxic situation, so I would not recommend that. The trends, let's see, smart homes have been kind of evolving for a while, but now they're bringing in the cooking appliances and the exhaust hoods, and they're Wi-Fi connected and computer and smartphone connected. And you can watch your recipes or TV or whatever from your microwave, so you never have to leave your kitchen. And consumer air sensors have really picked up over the last several years, and there's a lot of affordable ones out there, and LBL and others have done a lot of testing to show how well they perform. And so they're kind of semi-quantitative, but they give you kind of a good relative index of how well you're doing for particles and then CO2 and temperature and humidity in some cases, depending on what your sensor is. The ones for NO2 and other gases I don't think have developed so well yet. But the other thing that I just noticed, I'd seen this in commercial buildings, but they're now marketing it for residential. And it's an air quality sensor that goes in the ductwork by your central air handler and maybe your return air. And it monitors the airflow and the particles and whatever. And then you have a remote controller that you can change your airflow or track the data. It's all kind of web-based, I think. And there's also a kind of a trigger system. If your particle or other pollutant levels get past a certain warning level, it will kick in your ventilation system. So that's could be quite handy if you have, say a wildfire situation and you have very sensitive, health-sensitive occupants. Another product trend is electric grills like the George Foreman grill. They've been around a while, but a lot of these small appliances are really, I think, booming lately because of the pandemic, and people are cooking a lot more at home. And also with the increase in multifamily building construction, people don't need big stoves. They're not doing a lot of major cooking. They're just, or they want something convenient that they can just let it simmer all day and come home later and eat. And so crock pots are having a big resurgence, but now they're getting real fancy. They've got ceramic liners that you can remove. They've got features that you can put on the stove and then drop into the crock pot, or you can braise meat or even do frying. Let's see, on the number 5 is a fryer. The number 3 is a multi-cooker, so you can do not only, the simmering, but you can probably make yogurt at lower temperatures, and then you do higher temperatures for braising meat or doing stir fry or whatever. And the good old pressure cooker number 4 is now a high-tech electric model. So next steps, well, we basically need to rally the troops and educate and train the public. So spread the word and train the trainers and make it go viral that you need good range hood ventilation and quiet ventilation. And also the California building energy standards are being updated to improve the capture efficiency, noise, and airflow rates. So we need to push that and make it health protective. And once we have the HVI testing and listing of range hood capture efficiency, it should allow consumers to pick much better range hoods and quieter range hoods. And there's new sensor technology that will allow people to actually get data and see how well their range hoods and their air cleaners and everything else are doing. And so in conclusion, control the source. Keep that pollution in the pot, keep a lid on it, keep it under the hood, and keep it out of your lungs. And keep it quiet. And here are some resources. The top one is that I did updated over a year ago, I think. And there's lots of tools and presentations as well, and some references. And then LBL has a good site with all kinds of summaries and publications and tools, and they've done a lot of monitoring and modeling work. And then I won't go through all of these, but some of these I just discovered that have like great videos and some information on food mutagens and so on. And then the various NGOs have some good summary documents like RMI, PSR, Mothers Out Front, Sierra Club. For more information, there's the website, or you can just Google ROCIS range hoods or ROCIS.org range hoods, and you can access that information. And it's a living document. We have updated it periodically. There's a discussion group under Building Performance Community that's an open forum for anybody for Q&A and whatever. And then if you could please link your web pages to our web pages, and if you have any feedback, just contact Linda. And finally, there's my contact information. And thank you very much.